Factoring out a GCF. So that's what we're going to discuss in this video. I'm going to start with basic stuff and we're going to work our way up to a little bit more complex things by the end. So first thing I'm going to do is I'm going to start out with what in the world is a GCF. A GCF is known as your greatest common factor. So I'm going to start off by giving you the idea of what the GCF basics, and then we'll move to what that means in Algebra 1. So to find the GCF between two numbers, so say I have the numbers 16 and 24 here, if you want to get super basic, basically you need to list out all the different factors or all the numbers that can be multiplied together to give you 16. So if you want to get super basic to start, you just take 16 and I start by dividing by 1. And notice how I got a whole number there. That's what we want. So that tells me that if I take 1 and multiply it by 16, 1 by 16, I'm going to get 16. So I'm going to make a list here from least to greatest. That's why I put the 1 down here and the 16 down there. Then I'm going to keep growing this list. So now I'm going to move to 16. Instead of dividing by 1, now I'm going to go up to dividing by 2. And I got 8. So I know 2 times 8 gives me 16. So I put a 2, put an 8. Then I'm going to try 16 divided by 3. Now, some of you might be able to know off the top of your head the 16 divided by 3, and you say no. Others, if you're struggling, use a calculator. So I have 3 and then 5.3333. We do not want decimals here. So I don't want to say, oh, 3 times 5.333. No, we're not going to do that. So that doesn't work. So then I go 16 divided by 4, and I got the same number there, which is 4. Now, I know when to stop doing this list once I run into numbers that duplicate. So here's a 4, and it duplicated. I showed a 4 there. Once we have a duplication, that's when I know to stop. And this will make a little bit more sense in my second example. So that's where I'm going to stop on this list. 1, 2, 4, 8, and 16 are my factors. So now I'm going to do the same thing, but I'm going to do this with 24. So I need to list out all the numbers that multiply to 24. So we're going to have 1 all the way up to 24. Then we're going to take 24 divided by 2. And I realize 2 times 12 gives me 24. Then I go to 3, 21 divided by 3. So I know 3 times 8 gives me 24. I'm going to keep going. 24 divided by 4. And I know 4 times 6 gives me 24. So I'll keep going. 24 divided by 5. Get a decimal. And I would stop there because 24 divided by 6 and 4 I already have. 6 and 4 I already have. So that's when I know, all right, time to stop there. So these are all factors here. Another way you can think about factors is think about all the numbers that you know that can divide into 24. Or all the numbers that you know can divide into 16. So I know I could take 16 divided by 1, 16 divided by 2, 16 divided by 4, 16 divided by 8, 16 divided by 16. All these numbers I know if I took 24 and divided by them, I would get a whole number there. So that's the factor part. The greatest common part is, well, when you talk about common, the C, what both of these have in common. So they both have 1s, they both have 2s, both have 4s, both have 8s, so on and so forth. So that's the common part. The G is for greatest. So we want to find the largest number that both of these have in common. So I'll kind of start up here, 16, not down here, 8, and I see I have 8 in both. So the GCF between 16 and 24 would be 8. Now we're going to take this and we're going to apply this to Algebra 1. So we're going to factor these polynomials. So we're diving into factoring here. So I need to factor out the GCF in the following polynomials. I'm someone that likes to take things piece by piece. So the first thing I'm going to do when I look at this is I have two terms here. I have a 4x squared over here and a negative 16x over there. I'm going to start by looking at the numbers only, so 16 and 4. Now what I'm looking for is I want the largest number, GCF, the largest number that I know can be divided into each of these. So I start with the smaller number over here. What could be divided into 4? Well, I could do 4 divided by 4. Can I do 16 divided by 4? Yes. Things you want to be careful of is don't forget the G part, the greatest common factor. Because some people will be like, well, I could take 4 divided by 2 and I could take 16 divided by 2. But we want the largest number that we know can divide into 4 and divide into 16. That number is 4. So we're going to start with that. Then I'm going to move to my x's. So I have an x squared over here and an x over there. So thinking of a GCF with variables is a little bit tougher. So I have an x squared and an x. By the way, if you're struggling with the 4 and the 16, you can make the list and all that and find a GCF if you want with the 4 and 16, but you don't have to. So looking at x squared and x, I'm going to write that all out. So if you have x squared, that is just x times x. And then down here with x, I just have a plain old x. So I need to find what do I have in common between the two of these. Well, I have an x here and I have an x there. I can't take any more x's in common because there's 2 up here and only 1 out there. So I only have 1 available in each. So I could take out just a single x. So that's our GCF between these two. Now we need to write kind of what's left over, and that's going to involve some division. So I factored out, or I divided out a 4x. So I'm going to focus on numbers first, then I'm going to go to variables. So let's start with 4 divided by 4. 4 divided by 4 is going to be a 1, so I'm going to start with a 1 here. If I have an x squared and divide by x, you need to think back to simplifying exponents there. If you have x squared divided by x, you have x squared, x the first on bottom, that just gives you an x there. So we start with a 1x. Notice I have a negative here, so I have a negative 16 divided by 4. Negative 16 divided by 4 is negative 4, and then I take x divided by x, which is 1. So I have this 4x times 1x minus 4. This is the polynomial factor, and that's using a GCF. So let's do one more example there. Looking for the largest number that can divide into 16, that could also divide into 14. So 6 can be, or sorry, I said 16, I meant 6. 6 to be divided by 6, but can I take 14 divided by 6? No. So let's think of the next highest number that divides to 6. What about 3? 6 can be divided by 3, but can 14 be divided by 3? No. So the next number, 2. 6 can be divided by 2. Can 14 be divided by 2? Yes. So I'm going to put a 2 out here. Then I have to deal with the variables. Again, I'm dealing with an x to the 4th and x to the 3rd. So x to the 4th, that's x times x times x times x. X to the 3rd is x times x times x. Look at what they have in common. So I have 1 pair of x's, 2 pairs, 3 pairs. So 1, 2, 3, I have an x to the 3rd available there. They have 3 x's in common, that's x to the 3rd. So now I just want to do some division here. So 6 divided by 2 is 3. If I have an x to the 4th, so I have 4 x's there, I take away 3, be left with just a plain old x. Then I'm going to go over here, I have a positive 14 divided by 2. Positive 14 divided by 2 is positive 7. If I have x to the 3rd, so 3x is available, and I take away an x to the 3rd, so I take away 3, I would have none left. So 2x to the 3rd, 3x plus 7 is my factors there. So I'm going to apply this to something we've kind of done already. So we're going to solve the following polynomials. Should be just one polynomial. We're going to solve this, and the way we're going to solve this is by factoring. So in a previous lesson, we knew how to solve when we had like x plus 7 times x plus 2 equals 0, because we took each piece, set it equal to 0, and solved. So we're going to do the same thing here, but we got to factor first. So I'm going to look for a GCF. So I'm looking for the largest number that I can divide into 3 and divide into 12. So I know I could divide this by 3. Could I divide 12 by 3? You bet. So I'm going to start with a 3. I have an x squared here, and an x there. So I have 2 x's here, 1 there. The most I can take or divide out from both of those is just an x. Now I need to do some division here. See what happens. So 3 divided by 3 is just 1. X squared divided by x is just x. By the way, you don't always need to write that 1, especially if there's an x there. We'll leave it there just in case. That's fine. 12 divided by 3 is positive 4. If I had an x and I take away an x or divide out an x, I have nothing left. So to solve this, all I got to do is solve these equations. So I'm going to have 3x is equal to 0. And that is, instead of just 1, because 1 times x is just x plus 4 is equal to 0. So solving those, I subtract 4, get x equals negative 4. And over here, divide by 3, I get x equals 0. And that was factoring polynomials with a GCF.